In this video, we will look at sections 1 and 2 of Karl Popper's text, Science, Conjectures and Refutations. And this is one of the most widely read and most widely anthologized texts of Popper, not so much the text as a whole, but these first two sections, because they give us a presentation by Popper of not only the content of his theory of falsificationism, but also the intellectual background of his theory of falsificationism and why he thinks it is important. So in a few pages, Karl Popper is going to try to explain his theory, explain how he got to that theory, and explain why that theory is so useful in our thinking about science. So let's look at what Popper is going to be doing. Well, the first thing that Popper does is he tells us what the problem was that he was engaged in when he came up with falsificationism. So the problem he was engaged in, by that I mean the problem that he wanted to solve as a young thinker. Right? He's thinking about science, and there's one thing that especially strikes him as worthy of knowing, as worthy of solving, and that turns out to be the problem of distinguishing between science and pseudoscience. This problem is also known as the problem of demarcation. To demarcate is to sort of make a line around something to show us its borders. And so the problem of demarcation would be the problem of showing where science ends and where something that looks like science but that isn't science, pseudoscience, begins. So let's say a little bit about pseudoscience. Pseudoscience is an inherently negative term. Nobody calls their own field a pseudoscience. Because if you call your own field a pseudoscience, you're saying, well, we're sort of claiming to be scientific, but we're not really scientific. And of course, nobody is going to say that, at least, not on the record. So one relatively uncontroversial example of a pseudoscience, which Popper briefly mentions, is astrology. Right? If somebody takes astrology seriously and says that they really can predict the future by, calculating the position of the planets at the moment of your birth or the moment of your conception or something like that, if somebody really claims that they can do that, and they claim to have theories that are true about the world and so on and so forth, most people will tend to say that what they are engaged in is not real science. It is pseudoscience, right? Maybe there were times in history, well, certainly there were times in history, when astrology was taken very seriously, and when there might have been actually good theoretical reasons for believing that astrology had to be possible, but that's not now, right? I mean, given what we know about the world, astrology, it's hard to take it seriously as a real scientific discipline. Something that maybe has a bit more influence in society nowadays is alternative medicine. Now, alternative medicine is not monolithic. It consists of many, many different approaches. But critics of, let's say, one particular approach of alternative medicine would tend to say that it is a pseudoscience. That here are people who make real claims, right? They claim to be able to heal patients. Maybe they even claim to be able to do that better than traditional medicine. But, if we look at their actual evidence and especially maybe at their methodology, at the way they amass evidence, that they, test their theories, that they come up with their theories, and so on and so forth, something seems to be wrong. At least that is what the critics would say. And of course, the practitioners might not agree, but something seems to be wrong, right? Something seems to be wrong in the sense that they're not really engaged in the scientific method. And of course, these kinds of questions have a lot of influence. For instance, when it comes to medicine, questions about which parts of medicine are really scientific and which are pseudoscientific is going to determine, among other things, what things your insurance is going to pay for or what things your government is going to fund. So questions about science and pseudoscience have real life consequences. And so Popper's question about how to demarcate, how to distinguish between science and pseudoscience is at least at first sight, an important and serious question. Okay. Now what Popper is going to do next in the text is he is going to talk about one way of thinking about science, about what a science is, that according to him is or was very influential, but which he thinks is critically mistaken. And his own philosophy is going to sort of be an answer to that. Here is how he first describes it. He says, I knew, of course, the most widely accepted answer to my problem, that science is distinguished from pseudoscience or from metaphysics, and I'm going to sort of leave that aside for a moment, because that is, the word metaphysics there has to do with certain debates in philosophy in, the first half of the 20th century that are not really important for the rest of this particular lecture. So distinguished from pseudoscience by its empirical method, which is essentially inductive, proceeding from observation or experiment. So the view that Popper is going to react against is the idea that science has, first of all, an empirical method, so a method that is based on observation. Popper doesn't disagree with that, but a method that is essentially inductive, right? And here inductive means that what scientists are supposed to be doing is they are supposed to, amass evidence that supports one theory or another theory, and then to sort of end up accepting the theory that is best supported by the evidence. Right? So I get evidence and more evidence and more evidence, and if it turns out to support theory A, then I ought to be accepting theory A, and if it ends up supporting theory B, then I ought to end up supporting theory B, and so on and so forth. Right? That is what science does. We amass evidence in order to show that certain theories are true, or maybe that they are probable. Right? Maybe we never know about the truth, but at least we can show that certain theories are probable, probably true, or more probable than the other theories, or something like that. And that is how science works. It works inductively, and we call these observations that fit a theory, that support a theory, we call them verifications or confirmations. Those are two words that Popper is going to use. A verification or a confirmation is an observation that shows that a theory, well, it doesn't show that it's true, but it supports it. Right? It shows that it's more probable than maybe we thought before we made this observation. Now, Popper thinks that this is not the right way of distinguishing science from pseudoscience. And so the next thing he tells us is this. He says, on the contrary, I often formulated my problem as one of distinguishing between a genuinely empirical method and a non-empirical or even pseudo-empirical method. That is to say, a method which, although it appeals to observation and experiment, nevertheless does not come up to scientific standards. The latter method may be exemplified by astrology, with its stupendous mass of empirical evidence based on observation, on horoscopes, and on biographies. So what Popper is claiming is that there actually is an entire way of doing pseudoscience which uses an empirical inductive method. Right? It brings in observations, it comes to claims based on those observations, and yet it's not science. And so this standard theory of science, which Popper also calls inductivism, or, the theory of science that thinks that we do induction, that we want verifications or confirmations of our theory, that is wrong, because it cannot really distinguish science from pseudoscience. Now, the theories that Popper is going to use in order to make his argument are four. One of them is going to be an example of a good scientific theory, and the others, three, are going to be examples of pseudoscience, according to Popper. The example of a good scientific theory is going to be Einstein's theory of general relativity. And that is a pretty complicated theory, and I don't want to say a lot about it, but I want to say a little bit about it so we can understand what Popper is talking about. So one of the things that Einstein's theory of general relativity predicts is that massive bodies, like stars, right, bodies with a lot of mass that are very heavy, that massive bodies curve space, right? Space itself gets curved by massive bodies. And so what we would expect, for instance, when a ray of light passes a massive body, well, here space is curved, and so it's not going to go straight through, it's going to go like this, Well, actually, that is what straight through is going to be, but from our perspective, it looks a little bit weird. Okay, so how could you find out whether that is true? This is a prediction that Einstein's theory makes, right? Or well, it's something that Einstein's theory says is the case, and now we would like to get a prediction from that we can actually test. Well, suppose that you look at light that comes very close by the sun, right? So maybe a star is shining right next to the sun, and we look at the light from the star as it passes the sun, and we check out where we see the star, right? And now we should be able to see whether the light went straight past the sun or whether it bended as it got past the sun. Well, one little problem with that, the sun is pretty bright. And so if you actually look at the sun, you're not going to see any stars, right? How to solve that problem? Well, you wait until a full solar eclipse, right? If the sun is eclipsed by the moon, then we don't see the brightness of the sun so much, and then maybe the stars are visible. Still, we might need some pretty good equipment, but, it seems to be possible. And so this observation was actually made by Eddington, who went to a place on Earth where there was a solar eclipse, and he made the measurements, and he calculated where the stars ought to have been and where we saw them, and it turned out that Einstein's theory had made the exact right prediction. Okay, so Einstein's theory makes a prediction, kind of weird. I mean, who has ever heard about space bending? It makes a prediction about where we're going to see the stars when we watch them right next to the sun during a solar eclipse. That prediction could have been right or it could have been wrong, but it turned out to be right. And Popper thinks that this is a prime example of a scientific success. We'll talk about that more later, but this is sort of the basic shape. The other theories that Popper talks about are Marx's theory of history. So that's basically the theory of history as the struggle between classes, which is supposed to end up bringing about communism. And then Freud's psychoanalysis and Alfred Adler's individual psychology. We can't really delve into psychoanalysis or individual psychology. I don't know much about Adler. I do know a bit about Freud. We can't really delve into it a lot here. But let's first think about what shape these three theories have according to Popper. What they do for somebody who hears about them and who maybe is convinced by what they tell him. Well, here is what he says. He says, I found that those of my friends who were admirers of Marx, Freud, and Adler were impressed by a number of points common to these theories, and especially by their apparent explanatory power. So these theories have explanatory power. They can explain things, right? If I wonder why something is happening, then Marx or Freud can help me explain what is happening. Let's read on. These theories appear to be able to explain practically everything that happened within the fields to which they referred. The study of any of them seemed to have the effect of an intellectual conversion or revelation, opening your eyes to a new truth hidden from those not yet initiated. Once your eyes were thus opened, you saw confirming instances everywhere. The world was full of verifications of the theory. So in a verification, again, that is an observation that fits the theory, that makes it more probable than it used to be. Whatever happened always confirmed it. Thus its truth appeared manifest, and unbelievers were clearly people who did not want to see the manifest truth. And a little later, Popper tells us that the most characteristic element in this situation seemed to be the incessant stream of confirmations, the observations which verified the theories in question, and this point was constantly emphasized by their adherents. A Marxist could not open a newspaper without finding on every page confirming evidence for his interpretation of history. All right. So I think we can sort of understand the kind of thing that Popper is getting at from situations that are pretty familiar to us. Right? So suppose that you have a very strong political opinion. You believe that party A is right and, wants the best for the people, and party B is made out of crooks who want to destroy the country and are basically plain evil. Now, if that's your mindset, it's very hard to have it's very easy to have an incessant stream of confirmations, right? If one of the, people from your favorite political party says something you agree with, you think, wow, see, these are morally good people who want the best thing for our country. If one of the people of party B says something you disagree with, which they tend to do, you think, they are so evil and stupid and they want the worst thing for the country. More importantly, maybe, or even more better as an illustration, suppose that a politician of party B does something bad, right? They're in the news and they're doing something bad, and you're like, haha, see, they're all evil. Now, if a politician from party A is in the news doing something bad, you're like, yeah, that's just how the media would report that, right? That's not the real truth. This just shows that the media has been corrupted by party B. Or suppose that a politician from your favorite party does something good, and you're like, see, they're all great people. Now a politician from party B does something good. You're like, yeah, that's just cynical posturing, right? They're just doing that to get more votes. See, if that's your mindset, you get an incessant stream of confirmations. It's what we tend to call confirmation bias. We can interpret sort of everything in terms of our theory, like fitting our theory. And this seems to be the kind of thing that Popper is describing. And maybe correctly, in the sense that maybe his friends, who were Marxists or Freudians or whatever, really acted this way and looked at the world this way. Okay, that's possible. But Popper is, of course, making a stronger claim than that. He's not just making a claim about his friends and saying that he had to talk some sense into his friends. He is claiming that what we are looking at here is a fundamental feature of these theories, certainly of Freudianism. In section 2 of the text, he's going to say he's going to be a little bit more circumspect about this when it comes to Marx. But let's take Freudianism as an example. The way that Popper thinks about Freud is this. He says every conceivable case could be interpreted in the light of Adler's theory or equally of Freud's. A little bit later on, I could not think of any human behavior which could not be interpreted in terms of either theory. It was precisely this fact, that they always fitted, that they were always confirmed, which in the eyes of their admirers constituted the strongest argument in favor of these theories. It began to dawn on me that this apparent strength was in fact their weakness. So, Popper wants us to think about the situation as follows. Suppose that I meet someone who is drunk every day, except when he is, he's drunk every day, and meanwhile he engages in decadent feasts. He eats everything that he sees. He is engaging in fornication. What will Freud say? Well, Freud would say that, and here I'm going to use some Freudian terminology. Freud could say that in this person, the id, which is sort of the part of the person that really sort of wants to satisfy the primary drives for food and drink and sex and stuff like that, that the id is too powerful in this person. There's no ego and no superego strong enough to keep the id in check. Okay. Now we find someone who is so uptight that they never want to party at all, right? They're never having any fun. They're just serious. They're just thinking about duty and morality and I don't know. And so Freud could come along and could say, oh, in this person, it's the superego that predominates, and the id and the ego itself are sort of, they're too weak. This person is dominated by the kind of conscience, by the kind of conscience that was put into them by society, by their strict upbringing, and so on and so forth. So, two completely different cases, one of a completely dissolute person, one of a holier-than-thou person, and Freud could explain both of them. And the way that Popper wants to think us about, that in this way, He wants to say, well, look, here are two completely different things that happen. Freud can explain both of them. They fit his theory equally well. So if you're a Freudian, you're seeing two verifications of the theory, two confirmations of the theory. But everything is a confirmation of the theory. And so this is actually quite meaningless. Right? Whatever you see, you can always come up with a Freudian explanation. And so it really doesn't show you anything. And now Popper can make his crucial move, which is to point at the difference between a Freudian theory and an Einsteinian theory. Because the Freudian sees all these kinds of behavior, and whatever happens, he can always come up with an explanation. Whereas Einstein makes a risky prediction, something that could be true or could be false, and we can test it, and if it turns out to be false, then the theory is falsified. And that is what real science is, according to Popper. Right? According to Popper, real science is about coming up with a theory that makes a risky prediction, or hopefully many risky predictions, which can then be tested, and if the prediction was wrong, the theory is falsified, we know it to be false, and we throw it away. Right? And we have to come up with something new. That is what real science is, according to Popper. It is making risky predictions, so it's having theories that actually can be used to make risky predictions, making risky predictions, testing them, and then potentially falsifying the theory and throwing it away. And so that is what Einstein and the people working on Einstein's theory are doing, and that, according to Popper, is what a theory like Freud's lacks, because Freud's theory fits any behavior, and there's no observation that could possibly show it to be false. Okay. I want to say a couple of things about that. The first thing we should say about that is that it is unclear that Popper is doing justice to Freud. In fact, I would say it is clear that Popper is not doing justice to Freud. So, first of all, there are, of course, both dissolute and uptight people in society, and so a good psychological theory had better be able to explain both. Now, a theory might be able to offer explanations for both of them that are in turn testable, right? Suppose I say something like, I'm just making something up. Well, both dissolute people and uptight people always come from very strict upbringings, but the difference between them is that the uptight people are socially successful, and that's why they sort of feel like they are worthy of their parents' love, and they sort of keep their moral system intact. But the people from the same kind of upbringing who are not very socially successful, who feel that they're not worthy of following their parents' commands, they all turn into these dissolute, immoral people. This is false, right? In fact, it's good. It's good that it's false, because that means that we know that it's false. We know that it's false because if we check out the actual ways that people react to things, and the actual life histories that they've had, then it doesn't fit the simplistic scheme that I've just been giving you. And so this is very easy to falsify. Right? So if we want to know whether Freud's theory is falsifiable, whether it can be tested, we don't just need to know that, it offers an explanation for both one type of behavior and another type of behavior. Of course it does. We want to know what that explanation is, and whether that explanation makes any claims that are testable. And it is a curious feature of Popper's text that he doesn't tell us anything about Freud's theory that allows us to determine whether Freud's theories are testable or not. So Adolf Grünbaum, for instance, has written about this quite extensively and argues that Freud's theories not only are testable, but Freud himself saw many of them as falsified and then rejected them and had to come up with something new. So it's very curious how Popper approaches something like Freud's theory. He only has his made-up example, then tells us that, this theory can explain anything, doesn't delve into what those explanations look like, and really never gives us any reason to suggest that Popper's theories are not testable. And the same surely holds true for Adler and Marx. Okay, so that's one thing I want to say. Clearly, Popper is not really doing justice to Freud here. He might also not be doing justice to the fact that science actually wants to explain things. And that in some scientific disciplines, maybe explanation is more important than prediction. Especially, for instance, scientific disciplines that are about the past. I mean, historians, for instance, are not really in the business of predicting anything. They're in the business of explaining things. Does that mean that history is a pseudoscience? Okay, I don't want to delve into that here, but those are questions that should be raised by what Popper is saying. Finally, I want to say something about the idea of a confirmation. Popper insists that only a risky prediction, right, a prediction that might also have turned out to be false, that could well have been false, is scientifically significant. And he suggests that these inductivists, these people who believe in confirmation, don't see that point. I must insist that this is absolutely false. This is a completely wrong presentation of what any inductivist philosopher of science has ever said. Any serious theory of confirmation is going to tell you that a prediction that is risky, but that turns out to be true, is a much stronger confirmation than a prediction that is not risky, and that turns out to be true. So if I make the claim, here's a theory, if I make the claim that every human being can learn to solve a particular mathematics problem within an hour. Okay, suppose that's my theory. Every human being can learn to solve a particular mathematics problem, call it X, within an hour. Well, that sounds kind of unlikely. Suppose that I perform a test with a famous mathematician, and it turns out that this famous mathematician within an hour is able to solve problem X. That doesn't really confirm my theory very much at all. And that is what somebody who believes in induction would say too. This is sort of the least risky case, the one where we most expect it to be true. If it turns out to be true, it's not much of a surprise, and it doesn't teach us very much. Now, if I can teach a baby, a 2 weeks old baby, to solve this mathematics problem within an hour, okay, then we're talking, right? That would seem to be the kind of case where we don't expect my theory to be true. And if it turns out to be true, wow, I mean, that, sort of really is a gigantic confirmation of my theory. This is something that any inductivist philosopher would say. So Popper really seems to be sort of criticizing a straw man much more than a real philosophical position. Okay, so that's the sort of methodological criticism I wanted to make here. And then what I want to do is, okay, I've made the criticism, now let's look at Popper's own idea. Right, because it's not, Popper's falsificationism, whatever its problems may be, and whether or not in developing it he does justice to other people, it's an influential and interesting idea. And Popper's 7-point summary here at the end of section 1 is actually a pretty great summary of falsificationism. So let's delve into that. I'm actually just going to read all of it out. Number 1. It is easy to obtain confirmations or verifications for nearly every theory if we look for confirmations. That is kind of right, with the caveat of what I just said. If by a confirmation you merely mean something that fits the theory, then usually it's pretty easy to think a way of making observations that are almost guaranteed to fit your theory. That is, on the other hand, not really a confirmation in the sense that it teaches us that it really raises the probability of the theory. Right? So, yes, Popper is right if he says that it's easy to find things that fit your theory or fit your preconceptions. Doesn't mean that an inductivist philosopher of science would say that those are good confirmations. Right? So if we keep that in mind, okay. But this is the reason that Popper doesn't really want to talk about confirmations or verifications very much. 2. Confirmations should count only if they are the result of risky predictions. That is to say, if unenlightened by the theory in question, we should have expected an event which was incompatible with the theory, an event which would have refuted the theory. This is a point that the inductivist philosophers might agree with on Popper, but it's a good point, right? If your prediction was very risky, if we would have expected it to be false, but it turns out to be true, that is really good for your theory. That makes your theory really look good. And Popper's example of Einstein is a great example of that. So Einstein's prediction was really quite weird. People didn't believe it would be true. It turned out to be true. That gave a gigantic boost to Einstein's theory. Number 3. Every good scientific theory is a prohibition. It forbids certain things to happen. The more a theory forbids, the better it is. Here we have Popper's falsificationism, like full-blown. Right? A good scientific theory is a theory that tells us that certain things can't happen. And that means that if they do happen, the theory is falsified. Right? So a good scientific theory tells us what can't happen. It tells us what the world can't be like. And that means that there are opportunities for us to falsify the theory, namely by seeing that these things actually do happen. So, a risky theory is a theory that tells us that some things won't be the case. Number 4. A theory which is not refutable by any conceivable event is non-scientific. Irrefutability is not a virtue of a theory, as people often think, but a vice. So here is the distinction between science and pseudoscience. A theory that forbids things is scientific. A theory that doesn't, well, that's a theory that can't be refuted because there's nothing that can show it to be false, but that's also not a scientific theory, according to Popper's falsificationism. 5. Every genuine test of a theory is an attempt to falsify it or to refute it. Testability is falsifiability, but there are degrees of testability. Some theories are more testable, more exposed to refutation than others. They take, as it were, greater risks. So to test is to falsify, and we basically covered this already. 6. Confirming evidence should not count except when it is the result of a genuine test of a theory. And this means that it can be presented as a serious but unsuccessful attempt to falsify the theory. So we only talk about confirming evidence if it could also have shown the theory to be false, if it had come out differently, right? If the test result had been different, it would falsify the theory. Well, but now that it is like this, it confirms the theory. And number 7, some genuinely testable theories, when found to be false, are still upheld by their admirers. For example, by introducing ad hoc, like just out of thin air, some auxiliary assumption, or by reinterpreting the theory ad hoc in such a way that it escapes refutation. Such a procedure is always possible, but it rescues the theory from refutation only at the price of destroying, or at least lowering, its scientific status. So here what Popper is saying is that even if a theory is genuinely scientific, it is refutable, in order to be good science, the people working with the theory also have to act in a certain way. They have to be willing to give up the theory when it is falsified. But it's possible, and according to Popper, and he talks about this in section 2, according to Popper, in the case of Karl Marx's theory, this actually happened. The followers of a theory might become so fanatical, in a sense, that they will never give up the theory. And so, even though Marx's theory of history, according to Popper, made clearly testable predictions, and those predictions, at least some of them, turned out to be false, and so it was falsified, what his followers have been doing is they have been just reinterpreting the evidence or reinterpreting the theory in such a way that they can hold on to the theory. That, Popper says, there you have a scientific theory, but you don't have science. You only have science if somebody has a scientific theory and uses it in a scientific way, which means that they try to test it, that they try to refute it, and that they actually give it up when it is refuted. So, one can sum up all this by saying that the criterion of scientific status of a theory is its falsifiability or refutability, or testability. So then in section 2, he basically sort of looks back on the theories he mentioned earlier and sort of classifies them according to how they fit in this falsificationist story. And so, as I said, the Marxist theory, it was actually falsifiable, but people, they didn't accept the falsifications, and so they reinterpreted it. They gave it what he calls a conventionalist twist, and thereby destroyed its claim to scientific status. And again, about the psychoanalytic theories about Adler and Freud, he tells us that they were just irrefutable because all human behavior fitted them. And again, I don't think that Popper gives us anywhere near enough detail to make that claim. But that is the claim that he is making. Then Popper makes one more, maybe surprising, but not unimportant little claim here. He says that the fact that a theory is not scientific doesn't mean that it's unimportant. Right? He says, well, maybe something like Freud's theory, it might be full of really good ideas. So it might actually be very important. It might be the case that we must be very happy that Freud came up with all those ideas, but they haven't been really given the form of a scientific theory yet. Right? We have to think of ways to embed them in a genuinely testable theory. And then we could have something that is really genuine science. And so Popper tells us that pseudoscientific, that is not necessarily the same thing as bad. At least the theories are not necessarily bad, although the way that people act, when they act in a pseudoscientific way, that is bad. What they should be doing is taking their theories, making them testable, trying to refute them, and throwing them out if they are not, in the end, really falsifiable. Throwing them out if they are, in the end, falsified, if we find something that contradicts them. So, that is the basics of Popper's theory of falsification, as he sets it out in sections 1 and 2 of Science, Conjectures and Refutations.